Welcome to this new explainer. When we look up at the night sky or just think about our beautiful blue planet, it's pretty easy to assume we were created in this peaceful, perfectly designed environment. But today, we're going to discover that our existence on Earth is actually the direct result of an incredibly violent, chaotic, and frankly, destructive cosmic history. We're going to walk through exactly how the solar system was formed, and most importantly, we're going to follow Jupiter's epic, terrifying journey through the cosmos. Because as you'll see, that journey literally defined the destiny of our world. So we've all seen this classic diagram of the solar system, right? We all had this in our school textbooks. The sun is right there in the center. You've got the small rocky planets close by and the gas giants further out. Everything just looks so perfectly ordered right from the start. Completely static. It honestly looks like a perfect clock where every single planet formed exactly where it is today, just spinning away in a peaceful dance. But here's the thing. That sense of order is a total illusion. And we're going to completely shatter that illusion right now by looking at one really weird, unexpected number. 9 hours and 55 minutes. That is the incredibly fast time it takes Jupiter to complete just a single rotation on its own axis. Just to put that into perspective, it takes our Earth a full 24 hours. Now, what's really interesting about this slide is how much this incredible speed completely violates our basic intuition of physics. Look closely at the comparison here. Jupiter has 318 times the mass of Earth. If you hollowed it out, you could fit more than 1,000 Earths inside it. Logic tells us that something with that much mass, with all that inertia, should offer way more resistance to spinning. A heavy-loaded semi-truck doesn't just accelerate like a tiny sports car, right? But Jupiter spins faster than any other planet in our neighborhood. It spins as if it weighs absolutely nothing at all. Right at its equator, it's rotating at over 28,000 miles per hour. So how is that even possible? Well, to understand this, we have to look at a pretty simple physics principle, the conservation of angular momentum. Think of an ice skater spinning on a rink. When she pulls her arms in tight toward her body, she instantly spins much faster, right? Without anyone even pushing her. Now, Jupiter formed by contracting, pulling its cosmic arms in, which naturally made it accelerate. But here's the massive problem. According to the math, it's spinning entirely too fast even for that. The only logical explanation is that Jupiter captured an unnatural amount of angular momentum from somewhere else. It literally stole momentum that didn't belong to it. To figure out where it got it, let's jump back 4.6 billion years to the very first chapter of our cosmic history. Everything started as this massive, incredibly lonely molecular cloud of freezing cold gas and dust. It was completely quiet until the shockwave of an exploding star, a supernova, slammed into it. That compressed the gases, gravity took over, and the whole cloud collapsed and started spinning in on itself to form what would eventually become our home. And the way this material actually structured itself is just mind-blowing. It was kind of like a giant cosmic cotton candy machine. Right in the center, our newborn protosun was incredibly hot, just melting and vaporizing everything anywhere near it. But as the material spun and was pushed way out to the freezing exterior of the disk, to what scientists call the snow line, things started to change. Microscopic little pieces of dust and ice began to condense and stick together, exactly like sugar crystals forming cotton candy. So your distance from the sun basically determined everything about how you formed. In the inner system, where Earth would pop up eventually, it was blazing hot. Small fragments of rock were colliding in these agonizingly slow processes, honestly like cosmic bumper cars, sticking together through friction to form planetesimals. But out in the outer system, way beyond that snow line where water ice, methane, and ammonia were everywhere, totally different story. Something absolutely gigantic was being built out there, and it was happening fast. And that something was a young Jupiter. Forming just beyond the snow line, where it had an endless buffet of ice and rock, it rapidly hit a critical mass. At that point, the data tells us Jupiter essentially became a cosmic vacuum cleaner. Its gravity got so intense that it literally sucked up almost all the gas in its orbital path. In just 100,000 years, it ballooned to 90% of its massive current size. And once it became this monster, it started fundamentally altering the entire solar system. Okay, let's really dive into this, because this is the epic twist in the story, the grand TAC model. For decades, we assumed planets were just born exactly where they are today. Nope. The data tells us this giant, Jupiter, did not stay put. After forming, it actually started migrating inward, right toward the sun. It basically became a planetary wrecking ball, plowing straight into the zone where the primitive rocky planets were hanging out, and it just devastated everything in its path. Now, you might be wondering, how does an entire planet just up and move? Think of it like a slingshot. As Jupiter encountered countless asteroids and early planetesimals, its massive gravity caught them and literally flung them away, sometimes right out of the solar system completely. But physics says energy is never lost. So for every single object Jupiter violently expelled, it lost a tiny fraction of its own energy. And by losing that energy, it physically dropped into a lower, tighter orbit closer to the sun. It swept through and essentially wiped the inner solar system clean. Here's the crazy part. If Jupiter had just kept going on that path, there would be no Earth today. Period. It would have devoured or shattered absolutely everything. But then, an incredible cosmic miracle happened. Saturn. Saturn had also formed and was migrating inward right behind it. And right in the nick of time, it caught up to Jupiter, and they locked into this precise gravitational dance called a 2-3 orbital resonance. Basically, for every 2 trips Jupiter made around the sun, Saturn made exactly 3. That perfect synchrony created a gravitational pumping effect that stopped Jupiter dead in its tracks, grabbed it, and physically reversed its course, dragging it back out to the outer solar system. And that brings us right back to our hook. This is exactly why we started by talking about its rotation. Those inexplicable 9 hours and 55 minutes, that isn't just some random quirk of physics. It's a signature. It's a physical scar. During that wildly destructive round-trip journey, Jupiter interacted with millions of objects, either shattering them or hurling them into the void. And every single time it did that, it stole a tiny fraction of their angular momentum. That blistering speed it has today, that is the accumulated inventory of all the victims it left in its wake.
The destiny of Earth.
So what did all this chaos mean for us? Well, look at the aftermath, because it directly set the foundation for our home. Earth might feel huge to us, but compared to the gas giants, we are absolutely microscopic. And the reason we are so incredibly small is exactly because of Jupiter's path of destruction. During its rampage toward the sun, Jupiter swept up and emptied out a massive chunk of the building blocks that were originally there. We, the Earth, Mars, Mercury, we literally form from the crumbs, from the tiny leftovers that Jupiter left behind when Saturn finally pulled it away. Because of that, we're actually the weirdos of the stellar neighborhood. Thanks to the Kepler telescope looking at thousands of other solar systems, we now know it's completely normal to have massive, dense planets right up close to the host star. These enormous worlds we call super-Earths, and they usually have incredibly hostile environments, suffocating gravity and crushing atmospheres. If Jupiter hadn't acted as a giant wrecking ball to sweep away all that early material, Earth almost certainly would have become one of those massive uninhabitable super-Earths. And this brilliantly illustrates one of the most beautiful, poetic twists in all of science. The exact same chaotic gravity that nearly wiped us out of existence is also what gave us life. When Jupiter and Saturn retreated back to the outer solar system, their shifting gravity generated this massive disturbance that sent a barrage of ice-rich asteroids and comets plummeting straight inward toward the rocky planets. That intense period, the LEET-heavy bombardment, is very likely what delivered water directly to the bone-dry surface of the young Earth. It literally brought us our oceans. So I want to leave you with this thought. When you look at the impact craters on our moon, or the vast blue oceans on our planet, it is impossible not to marvel at it all. Jupiter destroyed way more than it ever left behind. It stole the material, basically emptied our inner neighborhood, but left exactly the perfect amount of leftovers to create a habitable world. If Jupiter hadn't gone on that chaotic migration, stealing all that cosmic, angular momentum, would we even be here today, conscious, wondering about where we came from? It's wild to think about, but our very existence is the legacy of the greatest storm in our solar system's history. Thank you so much for joining us for this explainer, and we'll see you next time.